Okay.
And almost there, almost there.
And now everyone knows I have a Minecraft chair, which should surprise very few people.
Uh, and impress them.
Yeah, clearly I am streaming from a dungeon.
Yeah. Why would anybody have a problem with you having a Minecraft chair? I get so I don't know if you know. Sorry, I apologize to everybody watching Pamela jiggle around on the screen. Okay, that'll do. Uh, so I've been into Minecraft or had been into Minecraft
That's
right
like
from the
the
beginning.
beginning.
Yeah, the
Yeah.
very beginning, and got the kids into it, and back in the beta and stuff,
Yeah.
and we went to the first Minecon in
Hmm.
2011, and there was only 2,000 people there. We met Notch, and they gave everybody capes for
Yes.
that first
Yeah.
conference, and and so we still have our capes. And I get an email every couple of weeks from somebody going, "Do you want to sell your cape?" Like, nope, I like it. It's cool.
Yeah. Yeah.
Yeah, yeah. So, um, all right, now it's working.
Okay.
People are gonna have to tell me. So we're using
Yeah.
my streaming service because Pamela got a new computer and
My
is
audio wasn't set up correctly
yes,
yet.
yes. That is always the big gotcha, which is that Max by default will not let you record the internal audio that is coming from the Mac, and so you have to go and install some kind of third-party software. Um, uh, the the OBS that I use for my streaming software works great, but um, but just other stuff. Audacity can't do it, so you have to install an extra plugin, and then the plugin lets you get access to that internal audio, and then you're set. So anyway, um, right, how's it going? How
Oh
was your
God.
trip? I can't hear you.
That's because I'm just sitting here shaking my head trying to figure out what I can say.
Uh, you
Florida
traveled
was,
to Florida and
and it was cold.
yeah,
It was so cold.
yeah,
I had a ticket that was a gift from my husband to go to Epcot for the Festival of Arts last Thursday. And it was so cold and rainy that I just changed the date on the ticket to like November, which was as far as I could change it
yeah.
without having to pay money because it was too cold to go to Disney on a ticket I didn't have to pay for.
Right.
And then, like, just everything going on in the world.
Yeah, yeah. I mean, we are 4 days away from going into a trade war.
Yeah. And the apparently there's a new tradition of crying at my keyboard on Mondays as new things get learned.
Oh,
So last week it was all of the diversity, equity, and
hmm,
inclusion cancellations, which means every program to fund teaching science in impoverished school districts was canceled.
yeah,
And I have friends who do that, who are just like, I no longer have a job, apparently.
yeah. But
And,
it's sorry. It's like deeper than that. I was seeing a post by Brian Dunning on Facebook, and with his nonprofit Skeptoid,
mm-hmm,
one of the requirements to get a 501c nonprofit, to get funding to it, in some cases you have to describe the all of the
mm-hmm,
diversity, equity, and inclusion programs that you're doing. And so literally every single nonprofit out there is going to have over the last decades expended a tremendous amount of energy to build the
yeah,
DEI into their organization. And
yeah,
then if they get any kind of federal funding, I'm not even sure how it works, um, then they're all liable,
yeah,
and at to varying degrees of potential lawsuit from the federal government. And so
yeah,
you're going to have, so every single charitable organization is going to have to sort of go through this process of dismantling their organization to sort of restructure whatever the new rules are.
And no one is sure yet.
Yeah.
And this is where one of the things. So on my Monday morning cry this week, the thing that hit is folks woke up to messages from the National Science Foundation that grant review panels that were supposed to happen today were canceled. USDA had similar messages. We're seeing calls for proposals from the DOJ getting pulled. So soft money programs, grant funding programs are either not getting reviewed. The funding for no-cost extensions is in purgatory. So another colleague who put in all of her paperwork on time for a no-cost extension, that hasn't gone through.
Yeah.
And so like I went to fill out my timesheet this morning and I couldn't.
Right.
For part of my paycheck. The work was done.
Yeah.
But can't get paid for it.
Yeah.
And
shame about that.
Yeah. And
Yes.
so like all the effort I put in since October to apply for federal grants, probably for nothing. But the thing that's killing me is we do have a pair of small grants over on CosmoQuest that are no longer on CosmoQuest. I've yeeted them from CosmoQuest into their own special domain set. No servers shall touch, no domain shall touch. Because I'm not going to do citizen science within CosmoQuest if that risks us being able to have, like we have in our Discord, a place where folks talk about queer in science and stuff like that. And I would have to delete that channel. I would have to delete all of our posts about women in science. I would have to delete all of that.
Yeah.
And I'm not going to do that.
Yeah. And I think about NASA. Like NASA has for years highlighted various people within NASA who, come from disadvantaged backgrounds or whatever. And they've just put targets. They all now have targets on their heads. Like all of those people who had been featured by NASA now are, someone's got a really easy list they can just go through and chase people out of their jobs.
Yeah. And the number of people who have reached out to me asking about how do I set up my own website is non-zero. And
ask ChatGPT. It's really good at it, or the new DeepSeek. Yeah, it's interesting. I mean, it's going to be a mess. It's just going to be a mess. Like all it is just going to make everyone's lives a mess for a while, until we understand whatever are the new rules. I mean, like it's even here. We can't, like in Canada, we can't plan for the future.
Right.
Right. Like we don't know what the future holds. I have no idea what the implications are going to be on my business.
My husband, who has a green card, he's Canadian, came down earlier and was just like, do I have to worry about this? Yes. And so,
yeah.
I mean, you may get new neighbors.
No problem. Sounds great. You'll love our city. All right, well, let's get on with our job.
Yeah. Okay. My hair in my chair are like opposite sides of the color wheel in the most amazing of ways. Sorry, just got distracted. I'm putting a window over my window. I can no longer see either of us.
That's best.
Oh, shoot. I have to open audition. Hold on. I'm sorry. I was having a how do I make the stream work moment until I realized I couldn't.
I'll let you struggle through that. I got to go talk to my wife for 1 second. I'll be back.
Okay. So we're also not going out on Twitch right now because, I just realized a little bit too last second that no, I am not set up to do this today. I'm going to sign out that computer from Adobe. The joys of getting a new computer are many, but so are the pains. So, if any of you out there are struggling, I'm right there with you. We're all on the struggle bus right now. Why are you full screening on me? I've hit this fascinating, I'm not sure what I'm doing wrong, but I keep clicking things and making them go full screen by accident. I really am so very confused, and I need to put my phone into do not disturb mode. Okay, phone is in do not disturb. You are back.
Okay. Sorry about that. All right, let's get started.
Okay.
Now you're ready?
This is episode
742.
New audio file. I should make sure it's using the right mic, because it has many to choose from.
Yes. It is once you get the new computer, it's not going to default to the right microphones. Yeah, you got to double, triple, quadruple check. I mean, I don't know if you sound okay to me.
Yeah, no, I had set for you automatically. I just need to make sure that Audition had the same thing. And it's going to record in stereo, and I don't know how to make it not record in stereo right now. So it's just, I'm sorry, Rich.
He'll have to flatten it. Okay, are you recording?
I am now recording. Whoa, my levels are really, really low. All right, we're just going to have low levels, and Rich can fix that.
He can fix that. All right, I'm also recording.
Okay.
Astronomy Cast, episode 742, Atmospheric Gravity Waves. Welcome to Astronomy Cast, our weekly facts-based journey through the cosmos, where we help you understand not only what we know, but how we know what we know. I'm Fraser Cain. I'm the publisher of Universe Today. With me, as always, is Dr. Pamela, a senior scientist for the Planetary Science Institute and the director of CosmoQuest. Hey, Pamela, how you doing?
I am doing well. I went from being very cold in Florida to now being very cold in Southern Illinois.
No difference.
I think at some point maybe I'll be warm again, but wow, the winter this year is very determined to get its presence known. How are you up there in Canada?
So we had been unseasonably warm. Like, I could have grown citrus here warm. We didn't dip below freezing for more than a couple of days, barely. And then a cold snap just came in, but still it's like just barely below freezing. But apparently next week we should get like the polar mass is going to move our way, and then we should get a little more seriously cold. Although, Vancouver Island seriously cold is -6 Celsius. I don't know what that is, in the 20s, I guess.
Yeah.
It's not too bad. Nothing as cold as Florida or Louisiana, where you see snow and stuff. So I think it's important for us to just sort of warn people that both you, as running CosmoQuest and such, and me as a Canadian, are about to go through an enormous amount of turbulence with the sort of all of the stuff that's going on politically in the U.S.
We're sorry.
Yeah. For you, you're having to sort of deal with the repercussions for the people you can hire, the programs that you can apply for, all of the grants you've applied for are all getting reevaluated, shut down, closed off. I'm about to go into a trade war with you. So we are now enemies, which is going to suck. And I don't know what the repercussions are going to be and what the implications are going to be for our ability to, hire Americans, which I I hire a bunch of Americans, so that may have to change our coverage. I don't really know what the ramifications are. We're going to see how this goes. So I just want to warn everybody listening to this in advance that you could see disruptions in our programs, in what we do, and it's just going to be us attempting to navigate what is now a much more complicated and uncertain time in what we do. So yeah. And I'm sure, what I'm explaining to you is a conversation that you're having across all of your organizations and companies and nations and all of that as we sort of chart this path forward. And so for all of us, I hope we're able to make this as uncomplicated and undisruptive as humanly possible, so that people can just watch the shows they like and enjoy the science they do their science and get work done as friends.
All we want to do is communicate science. This shouldn't be controversial.
Yeah, exactly. All right. Have you ever looked up into the sky and seen bizarre cloud formations that look like waves on the ocean? These are gravity waves, and not to be confused with gravitational waves. And they're caused by a balance of buoyancy and gravity. And of course, these have been seen across the solar system. And we will talk about it in a second, but it is time for a break. And we're back. So do you have your kind of classic favorite? Do you have times when you've seen gravity waves? I sure have.
Yeah, we live in a very flat part of the United States, a very, very disturbingly flat part of the United States. And because of that, we get these nice, stable air patterns that when something disrupts them, it will cause clouds to form in this set of stripes across the sky. And those stripy clouds are driven by gravity waves. And this entire episode is actually inspired by the fact that last Friday, it was finally sunny in Orlando, go figure. And I drove out to Cape Canaveral because I wanted to get some pictures of the new Blue Origin facilities. And there was this amazing set of contrails radiating away from a point on the horizon. And one of these contrails was cut perpendicularly by a bunch of gravity wave clouds. And it was just the wildest thing. And so I'm like, okay, let's talk about this, because clouds can get formed by so many different things. And gravity wave clouds are found throughout the solar system and probably throughout the universe. We just don't have evidence of that.
Right.
And they're cool.
Yeah. And so where I live, it's the opposite of you. I live on the eastern side of Vancouver Island, and we have a mountain range to the west of us. And so you'll get these low cloud formations that will be passing over the mountains, and it'll almost be like waves on the sea. That you can see where the air mass is oscillating as it's going up and down, and sort of, and as it goes down lower, you get this condensation, and then it goes up a little higher, and then you don't get any condensation, and you get these weird clouds that roll. We see them all the time in certain times of the year when the conditions are right. In the springtime and in the fall, we get these big, fluffy, what you would think are cumulonimbus clouds. They look like giant storm clouds, but they're not. They don't hearken rain. But at other times of the year, we get these really weird cloud formations, and it's pretty cool.
That is excellent. And that's the thing about gravity wave clouds, is they're driven, to expand on what you said with buoyancy versus gravity, by having nice, smooth layers in the atmosphere, and then something comes along and displaces one of those layers, and it sets up a harmonic oscillation. And that harmonic oscillation of something rising and falling too far and rising back up, that harmonic oscillation is what can drive these clouds. And when you have a nice, calm set of layers that then hit the top of a mountain, in your case, are disrupted by a temperature variation or something like that in my area, whatever it is that drives that localized instability, it then expands out and causes all these amazing clouds that we then see.
So what are the factors that will tell you whether or not you're going to get this kind of an atmospheric effect?
So you can't generally find them directly under the jet stream. There is just way too much turbulence going on. You need to have smooth, stable layers. You're not going to find them uh, where a front has just gone through where everything is turbulent. You're not going to find it over an area with a lot of thermal instabilities. Um, you need to start out from a position of nice, smooth air, the kind of conditions that you want if you're out flying an airplane, something without turbulence. And then in these nice, smooth conditions, you need something that is going to cause a displacement in the atmosphere. So the air hitting a mountain will do it.
Like a trigger mechanism.
You need a trigger mechanism.
Yep.
My favorite trigger mechanism is something that was theorized for decades and wasn't seen actually until just a few years ago. And this is total solar eclipse driven gravity waves.
What?
Yeah. This is one of those things that you have to be able to just launch weather balloon after weather balloon after weather balloon, starting a few hours before the solar eclipse, ending a few hours after, preferably like 12 hours before, 12 hours after. And gravity waves will already be forming off and on if the conditions are right. But when the conditions are right, having the shadow, which is a sudden change in temperature, sweep through is going to cause a rapid density change in the atmosphere, and that density change is a triggering mechanism. So you have air that was nice and warm in sunlight suddenly in shade, condensing and getting lower density. That displacement will drive horizontally moving gravity waves that propagate in the direction that the solar eclipse is moving across the planet.
Oh, that's really cool. So, you talked about how these can be seen on other worlds in the solar system. So where do we see these kinds of events across the solar system?
The best picture I've seen captured of them is actually Pluto's super, super thin atmosphere. So, do you remember when we got those images that had the atmosphere not quite backlit, but kind of backlit? We could still see a crescent Pluto, and there were these haze layers in the atmosphere.
Yep.
Those haze layers were caused by the propagation of gravity waves vertically through the atmosphere.
Oh, wow.
Yeah.
Yeah, because that I thought I had given you a softball, and I thought you were going to talk about a different planet, but because in some images that I've seen, but absolutely, that's great. I hadn't even thought about those.
Yeah.
Yeah.
That was a softball. I mean, it's an amazing, stunning image.
Yeah.
Pluto, yes, it has amazing topography, extremely high highs, extremely low lows, but its atmosphere doesn't have a whole lot to displace it, and so it's able to get these waves setting themselves up in the atmosphere.
All right, we're going to talk about this some more, but it's time for another break. And we're back. So the image that I was thinking of was some of the stuff we've seen on Mars.
Okay, so Mars has all sorts of different gravity waves going on. They have spotted them in a variety of the different levels of the atmosphere. They have started to figure out that it's gravity waves that are allowing effects from the lower atmosphere to propagate up to the upper atmosphere. There have been pictures from Curiosity of clouds with that distinctive set of troughs and peaks that are running parallel to each other for basically from everywhere you look out to the horizon. gravity waves are just like another day in the Mars
Yeah.
atmosphere. And it's amazing that, I mean, we know that the science here works on other worlds, but then Mars is just such a thin atmosphere that it's amazing that we can see these effects in its clouds, and we can.
Sometimes I mean, we are a video podcast because we record
Yeah,
on YouTube, but it would be great to show people like images. So if you're like in front of a computer, do a Google search for gravity
yeah,
waves Mars, and you'll see just these incredible images of what really look like ocean waves in the cloud structures on Mars.
yeah,
And as you said, these have been observed from the ground from Curiosity, but they've absolutely been observed from above with
yeah.
varying orbital spacecraft. And so what role do we think that these gravity waves have in the sort of evolution of the Martian atmosphere? Because it can, we know that it can go from clear skies all around to
Yeah.
global dust storms.
So during during the Martian winter, uh, they've been able to catch these clouds forming directly above Curiosity. Very first winter, it was one of the things that Curiosity caught. We are now realizing this is how lower atmosphere material is able to get pushed up into the upper atmosphere. So one of the things we've been really struggling with is, how is it that you can have dirt devils, dust devils, whatever you want to call them, and all these low level ground effects, then normal dust storms, and then shoot, there's dust all the way to the top of the atmosphere. And we're going to do a separate episode on just everything we now understand about dust storms, because it is mighty. I think
Yes.
you actually know more about this than I do right now. So if you can give a summary, that would be amazing. We both read different things.
Well, I mean, the paper that came out fairly recently was just them starting to understand what are the factors that come together to cause these global dust storms on Mars. Because you'll get regional dust storms, but there's very
Mm-hmm.
weird conditions that end up with you getting this entire global dust storm. And this was the kind of event that killed Opportunity. That it, although the wind doesn't blow very hard, because it's 1% the density of the atmosphere, you get this decrease in the sunlight available to the solar panels, and the spacecraft, or the rover, was already almost out of electricity anyway,
Yeah.
barely able to survive through the cold winter nights on Mars. And so this delivered the death blow as one of these global dust storms. And now it looks like people have done this, have done enough modeling of the dust storms on Mars that they've been able to realize that it is unseasonably warm conditions that lead to gives you a higher likelihood of the global dust storm forming and going to the entire planet. And so now you can sort of see, if you've got unseasonably warm temperatures, that's more likely to lead to these regional dust storms linking up and eventually creating this planet-wide storm. And so it's like, if the way we described it in the Universe Today story was, if the weather's nice on Mars, panic. Because it's gonna, because the dust storm comes next. Um, but so there's this situation on Mars where we have these diurnal tides. So you get this
Yeah.
change in the atmosphere between day and night, and then these tides interact with the atmospheric waves and at different altitudes.
And gravity waves in general are most common near the Martian poles. They can occur absolutely everywhere. Curiosity saw them straight above it. But in general, the conditions that are right, the nice stable atmosphere, something causing a trigger, those circumstances are most common along the poles. There's an article in Science about this. I'm going to do something I don't think I've done before on Astronomy Cast, and just read you guys a quote that I love about this. The Martian environment is the exotic wrapped in the familiar. The sunsets are blue, the dust devil's enormous, the snowfall more like diamond dust, and the clouds are thinner than what we see on the Earth. And that is from a March 23rd updated article talking about gravity waves. It appears in the journal Science. And these conditions are essentially allowing these super thin, all but transparent, wispy clouds to have this undulating structure. And that is both, you have the horizontal propagation, which is what we're seeing in the clouds. There's also vertical propagating gravity waves, which is how things are able to get through the different layers in the atmosphere. And so there's a lot of complexity going on. And one of the unfortunate things is we don't exactly have a fleet of weather balloons that we can release from the surface of Mars to study these things in the same kinds of details that we're just starting to be able to do here on Earth. But at least we can image them, even if we can't directly measure the temperature, pressure, and humidity variations that are involved in them.
All right, we're going to talk about this some more, but it's time for another break. And we're back. So we talked about Mars, we've talked about Pluto, we've talked about Earth, but there are more worlds with atmospheres in the solar system. So where do you want to go next? Venus, Jupiter, Titan?
I was going to say Venus.
Sure.
So Venus has the biggest waves. They are the clouds are moving at 100 meters per second.
Right. Like it's important for people to understand. It takes 4 days for the air on Venus, the atmosphere on Venus, to rotate once, while it takes for the sun to come back to the same spot in the sky. It's 225 days. It's like 247 days for Venus to turn once on its axis. But the air turns, the weather turns every 4 days.
100 meters per second is a kilometer every 10 seconds.
Yeah.
That is just like mind-boggling to me. And we can see in images from Japan's, you're going to correct my pronunciation. Thank you. I didn't have to say it badly. You just said it. Thank
Japan's
you.
Akatsuki spacecraft. Yeah.
Planet C. I'm going to go with Planet C. I can say that. Has been able to pick up these sets of waves that are taking up roughly a third of the planet's hemisphere that we can see at any given moment, or the spacecraft can see at any given moment. And these waves that are taking place in the clouds, where you have these winds at these tremendous speeds, the waves are stationary. And this is the kind of thing that causes me to think, I chose the easier field going into astronomy as compared to meteorology.
Right.
And
was that like a direction you were thinking of going?
No,
oh, okay.
Never.
All right.
But like usually you're like, I'm an astronomer. I went the hard path. No, not compared to meteorology. And no one ever says, this is not rocket science. This is not brain surgery. This is not meteorology. Meteorology is the hardest of all of these folks.
Right.
So in trying to figure out what's going on, as near as they can tell, the weather patterns going over mountains, or as probably it was, big old volcano on the surface of Venus, was able to trigger a upward propagating gravity wave that created standing waves in the atmosphere.
Right.
So we are seeing a super complex situation that
you've got these winds whipping around Venus every 4 days, 100 meters per second. You've got what looks like a mountain range in the Ishtar Terra region of of Venus.
Venus.
Yeah, and so as the winds are whipping around, you're getting this oscillation that gets kicked in, and it is a permanent standing wave. And so you think about places. There's this amazing river in Germany that we saw, where the water was sort of going down this sluice gate, and it was this
I was
standing
about to
wave.
this was in Munich, yes?
In Munich, yeah, people surf
Yeah,
it.
yeah,
Yes,
exactly. I was
right.
going to mention the exact same thing. I
There
was
you
just
go.
doing what city was it?
Yeah, it was in Munich.
Thank
That's
you.
right.
Yeah.
Right by the Science and Technology Museum.
Yes.
Yes. So people were surfing in this, right? It's a standing wave. And so you've got this standing wave, this standing gravity wave in the atmosphere of Venus. And it really, again, I wish we could show you pictures, but it looks like someone has kind of wrinkled up a side of Venus to create this standing wave.
And it's that exact same scenario of you have an extremely fast moving fluid. We model atmospheres as fluids. It hits a disrupting surface. The mountain on Venus, the sluice gate under the bridge in Munich, and that disruption creates a waveform that appears stationary, although the molecules that are in
Yeah.
it, the fluid is constantly moving, the shape of the fluid is unchanging, and it's this fabulous combination that on Earth is caused by all the features of the geometry of the water, but on Venus, it's a gravity wave. It's a buoyancy versus gravity versus landscape
Yep.
issue, and it's just amazing.
And I mean, we can rattle off other examples, of ones that are seen on Jupiter, on Titan, Saturn,
Yeah.
Neptune. Neptune has the fastest winds in the solar system. So these exist across the solar system. But I want to kind of blow people's minds, and that is something that doesn't have anything to do with atmospheres, but also has something to do with gravity waves, and that is the spiral arms of galaxies.
Oh, I wasn't planning to go there, but yes, that's exactly what they are.
Right. Yeah. Yeah. So when you look at galaxies and you see the spiral arms, you are looking at gravity waves, standing waves. They are not that the stars themselves are turning around in the galaxy in the shape of that wave. It is this wave of material that is propagating through the galaxy. Hmm. For some reason, your audio has disappeared from the live stream. I don't know why. You didn't do anything. Yeah, I can hear you, but I can see that you're no longer. So I'm gonna have to delete you and bring you back. So hold on one second. Yeah. Let me try changing to Audacity. People will see my stream. And then come back to Meet. And can you talk? Yep. Nope. It's active. It's not recording. It is just crashed. Yeah, people can't hear you. So we have to. So I think we've reached the end. So we haven't reached the end. So hold on, everybody. We're just gonna. You're gonna only hear me, and Pamela's gonna be talking, and you're not gonna be able to see anything, hear her. But we just need to record her the end, and she's gonna record the patron thing. So, yeah, and then I may have to completely dismantle this to make this work, or we may have to shut it down. So I apologize. But I can't. I don't know. Like I think OBS just shit the bed. So yeah. Listen, you watch Pamela, but you can't hear her. Yeah, yeah. All right, thanks, Pamela.
Nay, Joanne Mulvey, Jonathan Poe, J.P. Sullivan, Just Me and the Cat, Kim Barron, Larry Dotst, Les Howard, New Zealand, Marco Iorasi, Matt Rucker, MHW 1961 Supersymmetrical, Mike Heisig, Paul D. Disney, Paul Esposito, Pauline Metalink, Peter, Philip Walker, Planetar, Rando, RJ Basque, Robert Cordova, Ruben McCarthy, Scone, Sergey Manilov, Simon Parton, Stephen Miller, Tim Garish, and Zero Chill. Thank you all so much for being here, for letting me mispronounce your names, and we will see you next week.
Thanks, everyone. See you next week.
Bye-bye. And then they saved.
Yeah, so it just crapped out. And now I was able to find a button that said restart capture, which I don't understand. It's very weird.
Like
yeah. The fact that it just lost your audio.
Yeah.
And apparently you froze for a second there. So
I've had OBS just do that to me before, and it's super frustrating.
Yeah. You can't trust anything. Computers are the worst. Life is pain.
It's true. All of it is true.
Okay, cool. All right, we're done. So does anybody have any questions for us?
Can they hear me?
Yes.
Okay.
Yeah, I've fixed that.
Okay.
I don't see any questions. So I'm going to nerd out for a second.
I appreciate this.
So there was a paper that came out last week, and I'm guessing you saw it, where astronomers have figured out a connection between coronal loops on the sun and the powerful flares that happen off the sun. And
that one I haven't seen.
Yeah, so this came out last week, and so it appears there's this oscillation in the coronal loops that give off this signal that a powerful flare is coming from a specific
Oh.
location. And this has been the holy grail.
Mm-hmm.
Up until this point, you get an hour's notice that a
Mm-hmm.
powerful flare is in the process of erupting. This gives you more like 6 to 12 hours of advance notice that there's going to be a flare coming from a specific location, a coronal mass ejection. So that's
Yeah.
really cool. And then the other thing, and this was just a paper that came out kind of at a recent sort of similar time, and
Mm-hmm.
this is that researchers use machine learning to they crunch data from 1993 to 2018 and built up this model of understanding how coronal mass ejections evolve and show up on the surface of the on the surface of the sun. And up until this point, again, you get about you get an uncertainty of plus or minus 12 hours of how long it's going to take for a coronal mass ejection to reach the Earth, from when you
Mm-hmm.
see the events on the surface of the sun to when we experience the radio blackout and interactions with the electrical grid and so on.
Yeah.
And they went back and they used this machine learning algorithm, and then they applied it to the 2024 May solar storm, and they got that uncertainty down to 1 minute. So they knew to within 1 minute when the we were going to first experience the coronal mass ejection. They were able to like calculate. They were able to predict all of the events that were happening in this active sunspot group on the surface of the sun, and would have been able to provide incredibly accurate measurements. And so now it's like these two papers are showing that finally we're getting some level of certainty out of understanding the sun, which is really cool.
And just as a reminder to everyone who's still hanging out with us, um, the northern and southern lights, the aurora borealis and Austra I can't say it.
Aurora australis.
Yeah, are most likely to be awesome generically. There's a cat hunting a skunk that's going to end poorly under my front patio. It's really going to end poorly. Um, anyways, sorry, that was just way too much strangeness. They are generally the best around the equinoxes, so March and September.
Mm.
This March, like, this is if you have been imagining going on a Northern Lights tour, do it now. Solar Max is amazing. If you don't do it now, you're waiting at least 11 years.
Yep.
Not every Solar Max is equal.
This is a good one.
Yeah. Find joy everywhere you can.
Yeah.
And
I highly recommend
yeah.
the trip to Iceland as a place to do this, because like it's such a great, there's so many amazing things to see in Iceland.
Yeah.
From Reykjavik, which is a really nice little European town, great hospitality. Like they've got great hotels, good food, lots of stuff in the city itself. And then you can take these tours to go see amazing waterfalls and the Diamond Beach and glaciers and volcanoes and all this stuff. And also you sign up with an aurora hunting group and they'll take you out every night chasing auroras. And they'll go as far, and the light pollution in Iceland is very low because there's the population is there's I forget how many people there are, whatever 500,000 people, 300, like it's a very low number of people in Iceland, and so it only takes you half an hour to get out of the city to the point that you've got nice dark skies and you can see the auroras, and can absolutely recommend.
Yeah.
Okay. Zapfan asks, any thoughts on Venus's gravity wave and its relation to slowing the rotation of the planet?
I haven't seen anything linking those two things.
No, me neither.
The rotation of the planet is most likely caused by a massive collision in the past.
Did you see the story last week about a
Pretend I saw nothing last week, because that is probably the case.
Okay, so a planet with supersonic wind speeds where the winds are going 33,000 kilometers per hour.
No, that's wild.
Yeah, yeah. And so like just for comparison, the fastest winds in the solar system, Neptune, 2100 kilometers per hour, 2100, and on this planet it's 33,000.
How are they getting that? Is it from the line broadening of the atmospheric
Yeah,
lines?
so they measured essentially they measured the Doppler on the two sides of the planet. And so they
Okay.
were able to actually break up the spectroscopy, and so they could measure it on one side of the planet and measure it on the other side. And on the one side of the planet, they see it moving towards us. It's blue shifted, and then on
Yeah.
the other side of the planet, it's red shifted away from us. And they're able to measure the velocity difference between those and calculate it. And so it's a hot Jupiter. It takes 4 days. I may have this backwards. It takes four
Yeah.
days to go around its star, but the winds take 6 hours to go around the
Okay.
planet. It's like, Jupiter sized. So, yeah. Like
Yeah.
it just each time we keep finding these places that just defy our comprehension about what should be possible in the universe. I love it.
So
I love it.
I have a mini rant related to why I didn't read very much last week. So I was on a panel review for an agency I shall not name because I'm not supposed to. And when you do panel reviews, you get a stack of a gazillion proposals, in my case, 25. And you have to read all of these proposals and rank whether or not the humans behind the proposals should be funded and do all of these critiques, type everything into the system, yada, yada, yada. And in the end, you then get a token amount of money, usually a couple $100, in exchange for your time. And it it took me 2.5 full days to get through all of those proposals, doing nothing else
Right.
other than reading those proposals.
Yeah.
And and so this morning, when I'm seeing my colleagues and others on the socials of talking about the fact that the review panels they were supposed to be doing were canceled. These are people who, like me, put hours and hours and hours and hours and hours into reading things, many of which are just truly terrible. There are some really, really good things you read, and there are some really, really terrible things you read. And you have to read all of them, and you
Mm.
have to read all of them carefully so you can write at least somewhat thoughtful critiques. And the people who had already done all of that and then had their panels canceled
Right.
aren't even
Oh,
at the token amount of money.
that sucks.
Uh-huh.
Yeah.
Uh-huh. So yeah. Yeah.
Ouch. Um, so for people who are interested, I am about to post a new interview that I did
Oh, who with?
about the TRAPPIST-1 system, and it is just a phenomenal interview. So she is at the University of Washington. She's a PhD candidate.
Mm-hmm.
Hold on, let me get her name. Megan Gianluca. I don't know if
I
you know her. So it was not the interview that I was expecting. Like we were going to talk. Like she had done research into water levels and methane concentrations and how these can work back and forth in different exoplanetary systems, and that was all going to be very interesting and sort of how you could have habitability under like powerful flares from an M dwarf star.
yeah.
But I sort of opened up the conversation like, first I want to talk about TRAPPIST-1. And she's like, I'm glad you do because I'm very prepared for this. And so we spent an hour, no, 45 minutes going through each one of the TRAPPIST-1 planets and the current state of the exoplanet, of the atmospheric observations for each one of those planets.
Oh wow.
And so, 15 minutes talking about the history of the observations of the atmosphere at TRAPPIST-1b. right? And just like in enormous detail. And so if you're wondering like what's going on with the TRAPPIST-1 system, have they detected an atmosphere on the planets around the Earth-sized worlds in the habitable zone? This will give you the most comprehensive answer you could ever. It was
That's
so great. It was like,
amazing.
yeah, it was, and it was funny because at a certain point she was like, she must have been talking for 15 minutes, and she was like, do you have any questions? I'm like, no, I'm along for the ride now. I'm enjoying this. So it was great. It was one of the most entertaining interviews that I've been a part of in a long time. So that'll be released in like 5 minutes. So keep an eye out for that.
Two things that I did spot. One, Jonathan McDowell is raising funds to move his collection of astronomy books to a permanent home in the UK. And it looks like our favorite orbital police human is jumping to another nation for retirement, which I mean he's just going home. So I will be posting on my social media links out to that. And then a friend of the show, Stuart Robbins, is launching a Kickstarter to create the a new print round of the rainbow meatballs. They aren't actually NASA meatballs, but they're very reminiscent of the NASA meatballs, to remind everyone that the queers are here and they're going to space.
Right. That sounds great, man. Yeah. So I mean, back to the Jonathan McDowell part. Man, he's a legend.
Yeah,
Yeah.
yeah. It
Yeah. He's amazing.
it's and in so many different ways, from everything that he's done with the space report, which he has done entirely for free the entire time, because his day job at Harvard allowed him the luxury of being able to communicate on rocketry for free. He is known within the astronomy community in Boston, which is one of the largest astronomy communities in the US. Boston and Arizona are kind of the big ones. For the house parties that he holds for his library of books, for just being the mensch who keeps all of the summer RU students both in line and being human and enjoying being 20-something future scientists. He has influenced generations of astronomers, and our community is going to be a little worse without having him there as someone doing everything from mentoring to computer science to talking rockets.
All right, we reached the end of our hour, so I guess we should probably wrap things up. Thank you, everybody, for hanging out with us today, even through all of the technical issues that we faced. Hopefully, it'll all be forgotten. Pamela, what interesting thing is happening next that people should watch?
We just put live a new episode of Escape Velocity Space News, where every story is one that made me giggle or at least smile while reading it. So if you need a little bit of joy in your life, I encourage you to check that out. Unfortunately, our next episode is instead going to focus on a roundup of all of the effects the space community is currently seeing with all the changes coming down from the administration. That is less exciting. And I'm going to do a whole lot of seat of my pants programming, and anyone who wants to join me, please reach out, plg@psi.edu. We are creating a new platform for volunteer astronomy. We're not going to say citizen science, given all of the ICE activity in the US. That just seems like salt in a wound. Yeah, we're going to create something new so that we can keep, I don't ever want to have to delete posts on women in science.
Yeah. All right. Thanks, everyone. And we will see all of you next week.